Okay, I'm back, and now we want to do part 3 of the lab on double slit interference. But we're going to start with water waves. And so it says to go to FET, wave interference, and then click on interference. So we're going to go back to here. Now we've already done this part here on waves in general, and now we're going to click on interference. So we're going to do this one. Now, the difference is now we've got two faucets, and each of the faucets is going to be dripping water. So each of the faucets is going to make its own rings, and then the rings are going to interfere with each other to make constructive and destructive interference. So just as a review, when we did it for the single faucet, we had bright and then dim and then bright again. And so, and then underneath it, we could put what was the wave actually doing. So the bright areas were where the wave was at its maximum. And then the dim areas were going to be where it was at its minimum. Okay, so that you got bright and then dim, bright and then dim again. So that's the significance of the rings on that. So this time, so let's go back to the lab here. It says to turn on both of the faucets, and it's going to be causing circular ripples. And then where the ripples are coming together, they're producing areas that are brighter and dimmer. So in this picture here, you should notice that the blue area is brighter along this line. But then, do you see down here? So along this line and along this line, it got dimmer. And then you'll notice that over here, it's bright again. So along this line down here, it's bright, and then along here it's dim, and then bright, and then dim, and then bright again. So that's going to be areas of constructive and destructive interference. Now you should know which one's which. So in the previous part, you learned what constructive and destructive interference was, and then what did that do to light? Does it make it brighter or does it make it dimmer? And so we're going to be investigating that. So this is the concept of interference from two faucets making ripples. And so I want you to take a look at this picture here for constructive and destructive interference, and then each faucet is a source of waves. Now look at this one here. So here you've got this blue line represents the waves being produced by this faucet down here. This blue line represents the waves being produced by this faucet here. And then do you see that when this one's going up, this one's going down? So that is which one? Constructive or destructive interference. Okay, now let's take a look at this one. Now, this occurs at this angle. So this dotted line here represents the midpoint. So this slit down here represents where this faucet is dripping. This slit up here represents where this faucet is dripping. In between the two slits, so in between this slit and this slit is right about here. And that is where this dotted line is drawn from. And that is the angle in this picture. So you see the red one here? Okay, so each of those lines is going to be making a certain angle. And this would be a typical angle for destructive. But now take a look at this one. This is a different angle. So what we did is at this angle it might be destructive, but then at a different angle it might be constructive. So again, look at the blue line. Do you see that this blue line is going up at the same time that this blue line is going up? So that's constructive interference. So what I want you to do is you're going to start the simulation here. So we're going to turn on, okay, there's one of them. There's the second one. And they're going to start making ripples. And what I want you to be looking for in this picture here is places where it's extra blue and then places where it's extra dark. And so one of them is going to correspond to the constructive and the other one's going to correspond to the destructive. Okay, now look over here. You can change the frequency of the drips over here. You can change the amplitude, and you can change also the separation between the two faucets. So if you move this one back and forth, that's going to change the separation between the faucets. And what I want you to be looking for is, as you change the frequency and the separation, look at what happens to the angle. So the angle here, and you should notice that that angle will either increase or decrease as you change these different sliders here. So be on the lookout for that. So let's go back to it. So it says change the faucet separation, and notice how it changes the position of the interference angle. Then it says change the wave frequency, and note how it changes the position of the angle. And then I want you to think about, how does that change the wavelength? When I change the frequency, how does it change the wavelength? So here is that formula that you should already be familiar with, that speed is equal to the frequency multiplied by the wavelength. So we took this equation and we rearranged it for the wavelength. So now it's speed divided by the frequency. And be very careful. So this is V for velocity. This is frequency. That's the one that's on the bottom. And so you notice that as the frequency of the wave increases, the wavelength of the wave is doing something else. So indicate whether it increases or decreases. Now here is this is technical, okay? So if you're in my introduction to physics, algebra based, meaning no trigonometry, you would not need to worry about this equation. Okay, but I can't help myself. I wanted to show it to you. So here's the physics behind where the constructive and the destructive interference are coming from. And even in the general physics, so the next level up of physics would be trigonometry physics. And in trigonometry physics, you would learn this equation. But even in that, they don't really tell you where the equation comes from. That's calculus physics. So if you're interested, it's not that difficult. But if you go online and then go to derivation of this formula, you could find it and learn more about it. But that's not important to us. So what I want you to see is that you have different places where the bright and the dark is taking place in. So for interference along this line here, that would be an angle of 0. And so that would correspond to n equals 0. So notice that 0 times anything is 0. So that means the other side of the equation is 0. So 0 equals 0. But look at this angle right here. That's an angle of 0. And the sine of 0, is this getting too complicated? I hope not. If on your calculator, you got that button that says SIN. Put 0 in there and then press the button. And you get 0. So the sine of 0 is 0. So 0 on the left-hand side of the equation, because n is equal to 0, is equal to 0. Okay, then the next bright spot, let's say it's up here somewhere. Well, this would have a different angle. So n, this is the first one here. This is the n equals 0 down here. So n would equal to 1, and so the equation would say lambda equals d sine of this angle, whatever it is. So what's the d? The d is the separation between the slits. That's the separation between the two faucets. And so we could use this formula here to determine where it's going to be bright on the picture. Now, you're not going to do it. I'm just saying that this is the equation that's used to do that. So let's go back to the simulation here. And so we can change this from faucets to light. So if you see here is the faucet symbol. Okay, here is the symbol for a laser. And then we can turn on the laser. And then do you see that it's making bright and dark areas again? So let's stop it. And then notice that right here, right in the middle, it's bright, just like it was in this picture here. And then at a different angle, so all along this line right here, that would be n equals 1. And then up here, this would be n equals 2. So there'd be another line right here that would correspond to a different angle. So if you wanted to, you could actually get out a protractor and you could measure those angles, and then you could put it into that formula to figure out where it's constructive and destructive. So you could do that if you want. We're not going to do it. So by changing the frequency, so we can change the frequency up here, that's going to change the color of the light. So frequency for light is going to be color. So when we go to change the frequency, it will change the color of the laser. And again, that's going to be determining where these angles are at. So the angle is going to depend on the distance between the two slits. So that's going to be this distance here, and it's going to be depending on the frequency of the light. We could also do it with sound. So that's this one here. So if we click on it, and then we click on our two things here, hopefully. Well, play. All right, there we go. So now we got sound waves that are being emitted, but do you notice you've got areas where it's extra bright, areas where it's extra dim. And we could calculate the angles at which that's going to be occurring at by using this equation. So this again is the distance between the slits, or the distance between the faucets, or the distance between the lasers, or the distance between the speakers. And then this is the angle at which it occurs at. And then this is the wavelength, which again is related to the frequency by this formula here. Okay, now it says to click on the slits, and then this is what you're going to see. And it says to change the simulation from or start with one slit, and then we're going to go to 2 slits. So let's go back to here. And now we're going to go to slits. So we're going to go from interference to slits. So click down here, and now you got a single slit. So let's go ahead and turn it on just to see what happens. So these are like water waves, and as they go through the single slit, do you see how they're spreading out? Well, that's equivalent to one faucet. One faucet dripping is going to produce circular waves like that. Okay, but we're not interested in one slit. We want to do it for 2 slits. So over here, we're going to click on 2 slits. So now you got water waves that are approaching 2 slits, and then you see it's making that pattern. Well, that should look familiar because that's the same pattern that 2 faucets were making. All right, so now let's go back to the lab here. So press the green button. You got water waves. You're going to change the slit width to 40 centimeters and the slit separation to 180 centimeters. So move the sliders back and forth till you get those numbers. Take a snip of it, paste it into Microsoft Paint, and then draw the lines on there that indicate where constructive interference and destructive interference are occurring. So I got finished talking to you about what that's going to look like. So go back up to here, and it's going to look something like this, but you're going to be putting in your own lines to indicate where constructive and destructive interference are occurring. And then you're going to take that picture and you're going to put it down here. So, one more part left to do, part 4 on diffraction, and we're going to do that in just a moment.